Hello and welcome to our second conversation of the day. I hope you enjoyed our earlier conversation about autonomous trucking, and now we're looking at an entirely different use case for autonomous vehicle technology and, of course, the LiDAR that makes it all possible. Once again, my name is Ed Niedermeyer. I'm the co-host of the Autonocast and the author of Ludicrous, the Unvarnished Story of Tesla Motors. Ed, I've known Ed for a long time, but I'm not going to introduce him. You introduce yourself.
Hey, I'm Ed. I'm the founder CEO of May Mobility. I'm an engineer by training, been working on the DARPA Urban Challenge. That's where I got my start. And then worked as a faculty member at the University of Michigan. Go Blue. We had a big week this week. But got really passionate about how do we develop the technology, but also build a business around it at the same time. And I think we'll talk a little bit more about that. But that's probably the one thing to know about May, is that we already operate profitable sites, where I think we're the only AV company that makes money by operating AVs.
And sort of just introduce yourself briefly. Yeah.
I'm Sarush, co-founder and CEO of Aeva, and really excited to be working with May Mobility on our autonomous driving applications here.
Yeah. So we already have like the first commonality with our previous conversation, which is Aeva loves to partner with AV companies that are actually like making money, doing business, right? And not just sort of demonstrations and things. So, May is definitely not, May Mobility is not the best known name in autonomous vehicle technology. I think that's not entirely fair. I think you guys have been doing a lot of really cool stuff for a really long time, and you've accomplished some amazing things with a small fraction of the resources that a lot of other players have. We'll get more into sort of how that makes you different than other players and how that informs your collaboration. But for those who don't know May's story, sort of tell us a little bit about where it started and sort of how you've grown over the years.
Yeah. So first thing to know is May, we build our own autonomous driving technology. So we have our own stack, our own approach, and there's some scalability stuff that we can get into a little bit later. But while the product that we build, like that van over there, it looks to the rider like a Uber or Lyft. Like you're pulling out an app, you call the ride, the vehicle comes to you, takes you where you want to go. But what's different about it is who pays. So it's not the rider that pays. We contract with cities, so long-term contracts with cities that are using our services to improve the quality of their public transit. So the vision, the reason May exists is because I really am passionate about how do we make cities more beautiful, more accessible, more equitable, and fundamentally it comes down to how can we outcompete personal car ownership? How do we prevent individual car owners from taking their cars downtown, adding to congestion, leaving their car, requiring parking spaces? And the answer, in my mind, is really simple. You provide a better option. And the better option is going to be public transit with May Mobility.
Yeah, and so this is a really interesting thing. I know on the internet, I'm constantly running into people who say, driving automation technology, self-driving vehicles, I don't like it because it's cars, right? And everyone has this idea that that's what this technology is. But what you're describing is actually, it's very different, right? And in one way, this technology, so you're what's called a level 4 autonomous vehicle operator. Maybe you can explain what level 4 means and why that actually lends itself to something like transit more than something like a private car ownership.
Yeah, one of the big challenges is you're building a technology stack. Where is the vehicle going to be able to go? What's your operational design domain, ODD, if I say that in the future? And the bigger your ODD, the more you try to bite off, the more expensive your vehicle is going to be, and the larger the engineering team you're going to need. And we've seen that throughout the AV industry of companies that end up super big with massive burn rates because they're trying to do everything all at once. But here's the great thing about transit. Cities are already used to thinking about transit in smaller little geofenced areas. Hey, here's where bus route 22 operates. Here's where bus route 46 operates. And that means that we can go to those cities and say, bus route 22, that area is a great fit for us. So why don't you retire that bus that's driving around empty all the time, but costing you $150 an hour, and we'll replace it with a vehicle like that that provides on-demand point-to-point service that can carry more people than that bus was carrying anyway. But at the same time, bus route 44 over here, we can say, we'll do that one next year. Maybe the speeds are too high or there's something nasty about it. And so it gives us this very gentle on-ramp to grow the business where we don't have to boil the ocean on day one.
Yeah, no, it's so cool. And so, Suresh, okay, so we talked about the commonality, right? You have two partners here that are, really focused on operating a business, not just sort of doing demos and creating shows, stuff that we've seen too much of, I think, in the AV space over the years. Less these days, though. So you partnered with companies who are very focused, but at the same time, these are also two companies that are working on very, very different use cases. And the term you use, operational design domain. That means where is your robot driving, essentially, right? And so before we were talking about trucking on freeways, and you talked about how your LiDAR gives that really ultra, 500 meters, really, really, really long way. Probably don't need that so much in that range so much in your use case. But I'm just curious, right? This is the difference, and yet your LiDAR is working in both of these use cases. It's valuable in both. So talk to us about that.
Sure, yeah. Well, I think that's actually a great example of the type of kind of flexibility and power that our technology actually provides. I think, as we talked earlier, core part of a 4D LiDAR or FMCW is ability to actually scale performance going after, half a kilometer range, or being able to bring that down lower with much higher accuracy. And I think, you cannot say that about all types of technologies in the LiDAR space. Not all LiDARs are created equally in that sense, right? So I think, the beauty about our approach is, one, our ability to really focus on one platform, which is in hardware. Everything is integrated at the chip level, allows us to scale, allows us to bring costs down, allows us to increase reliability, allows us to make an automotive grade product, and allows us at the end of the day to make money. And then the second thing is, work with partners that are really focused on scaling, like Ed and his team and the May Mobility team, around and increasing that scale over time, especially where our technology can help achieve either use cases or help some of those ODDs that Ed was talking about. So that's where our focus is.
Yeah. So Ed, it's been really cool. I was checking out your latest vehicle here, and it's been really cool to see how your hardware has evolved so much over time. And actually, I want to start though, like, why is LiDAR so important for, again, I think it's easy for people to understand with a semi truck moving at really, really high speeds, with a lot of mass and things happen fast on the freeway and having that extra safety layer. But like in this, you're talking about slower speeds. You're talking, but there are different challenges in the domain that you operate in. Why is LiDAR important in making that happen, doing what you do?
Yeah. So the constraint that I give my team is that the vehicles that we build have to be able to make money. They have to solve a problem for a customer, and they have to be available now. So we are not designing systems for 2027, 2028. Yes, we're thinking ahead and planning ahead, but we're not just an R&D shop that's going to buckle down and then come out with a product in a few years. And so today, if you want to build a vehicle, you're going to use LiDAR because the camera technology is not there. The radars are not good. And the LiDAR, it works really well. And historically, we've used 905 nanometer amplitude modulated 3D LiDAR because it was inexpensive, it was available, and it allowed us to get that product on the road. But what's exciting about where we're headed right now is that the Aeva sensors open up new options for us. It's going to allow us to expand our ODD, expand our addressable market, potentially charge a price premium for having additional capabilities on the vehicle. And it's all being done with, at every moment in time, what is the best business case that we can build around those sensors? And the sensors are a moving target, and the new sensors have changed the equation.
Yeah. And I don't, I know as an entrepreneur, it's important to be looking forward and optimistic, but maybe could you share some of the challenges of the past of working with LiDAR, and what are some of the things that problems that pop up, and how is the evolution and the development of that technology sort of started to make progress on some of those things? Because you have to use this stuff. It has to work for you. And what are some of the challenges, and how's the progress been on that?
Yeah, I think in the early days, one of the biggest problems was point cloud density. There just weren't enough beams, and you would miss objects entirely. The world has come a long way since then, and beam density is really not the issue anymore. But then we started having problems. So every time the vehicle would drive up to a stop sign covered with that retroreflective tape, we wouldn't just see the stop sign, we would see a whole around the stop sign, sort of the blooming, glowing, which is a very common symptom with AM LiDAR. We'd also have problems with range. We always want to be able to see farther, and being able to see dark, shiny objects at longer ranges as well, especially it's wet out. And so one of the things that's exciting about the Aeva sensors is that they address a lot of these issues. We're going to get longer range. We're going to have more inherent immunity to blooming, more inherent immunity from sunlight, because we're not just competing with whatever photons happen to make it into the aperture. We're actually decoding, I should say, you guys are decoding a waveform, right? And you have a greater selectivity in detecting where that return pulse is. That's really a potential game changer. It's something we're really excited about.
And I would also add that, from our perspective also, I think having a partner like May Mobility also helps us to not only work towards just the maturization over the next 4 or 5 years, but also iterate quickly and learn in the today and the now, right? And we have already started delivering units, since our announcement of the partnership. We already working together pretty closely, and so that means that we have to be at a certain maturity to be able to do that and work together to provide a solution that's going to go on the actual road for commercial operation, right? So that focus on commercial operations, I think, also really propels us forward, which is, I think, helpful. It is a mutual win-win situation on both sides. Access to that unique technology or the velocity map, access to, scale and bringing that up. And then when you look at that layer in, throughout our additional partners, that's how we can gain the economies of scale and make it better for the overall industry, so that, Ed and his team can get cheaper and better sensors over time, and we can scale globally.
Yeah, so earlier in our conversation around trucking, you were talking about sort of the opportunities with software to sort of create different kinds of performance, to tune, your one piece of hardware for various kinds of use cases. Describe a little bit in a different use case than trucking, sort of what are you doing there? Like how are you using that capability to give Ed the best possible sensor?
Sure. So this is actually really interesting about, I think, the FMCW approach, which makes it really configurable, and we talked more about software defined, right? We usually use the word configurable, and what that means is same hardware, different settings. We can do so many different things. We can look at having the wide field of view with a specific scan pattern that can measure 200 meters. We can adjust the max range to 500 meters. For certain applications, you may not need to see 500 meters at all times. So what else can we do to maybe perhaps increase either the points on targets and really make make that those critical objects in the roadway for that driving applications on the autonomous robotaxi make more sense. So that's one example. I'm sure, Ed, there's other things that you can think of that we're working towards.
I think one of the big ones for us is this gives us a whole new channel of data to work with. So the Doppler closing rate data. It's not something we've worked with before, but it's something that we're going to have to go and sharpen our pencils and expand our models and retrain. But there's a huge opportunity here for us to figure out what is the best way to use that data. For us to learn from Sarush and the Aeva team about what this new capability, and for us to provide feedback and say, hey, this is working, this isn't working. What do we do? And then find the happy balance that's a combination of the hardware, the firmware, the software, the AI, the machines, and all the way up.
Yeah, and more data, of course, is better. New kinds of data, though, can be a real game changer.
Especially this. You've got a first principles reason to understand that Doppler data is going to be really valuable. You want to know whether something is getting closer to your vehicle. It's really strongly correlated with something that you care about. So it's very helpful. And you imagine a conventional LiDAR, if you're tracking it, the only way to estimate its velocity is to see it at one time, see it at the next time, and then, kind of hope that you're correlating them in the right way. Boy, if the sensor just says, here's the object and here's how fast it's going, kind of let's do it.
Yeah. So we've been, and I know we have a pretty technically sophisticated audience here at CES, but we've been throwing around FMCW and things like that. And so let's just take a moment and because I think you did a great job of explaining, that you're getting this new kind of data. But Suresh, on a technology level, let's just break down FMCW real quick, just so folks understand what we're talking about, and they have some context for what this Doppler data is, because it is really fascinating.
Absolutely. So, we're all familiar with LiDAR. I think that LiDAR is coming to the mainstream. It's becoming critical for making automated driving happen. I think LiDAR, typical LiDAR is based in time of flight concept. We call it 3D time of flight LiDAR. It sends pulses of light and measures the time it takes for the light to hit something, come back. That delta T, or that delta difference in time, gives you that distance very precisely. That's what's very important with 3D LiDAR. What we do with 4D LiDAR is, instead of sending maybe pulses, we send a low power continuous beam. And we don't really care too much about the power per se of the beam that we send, but we look at the frequency and other aspects of the light, very similar to how radars work. And by doing so, we can actually measure simultaneously the Doppler effect, or the velocity of every single point in the scene in addition to that distance. And we can measure its magnitude and its orientation. And that's something that when you then look at that at the object level, it starts to get really interesting. And, you can see on the screen later, as people walking by here, different parts of the body are showing different velocities. When it's stationary, it's looking more white. If you plant your leg, parts of it's looking red or blue. And all that is not just to show colorful things. It's actually, can be quite powerful to help the autonomous driver at the end of the day make the right decisions around what the object is going to do, so that he can make those decisions of what it should do. So that's where the power comes.
So yeah, prediction is sort of, in a lot of ways, the heart of the autonomous driving challenge, right? It's one of the very most difficult things. And so what we're talking about is, right, with the standard LiDAR, you can see, okay, there's something here. And if it's, you're getting a good point cloud, you can even see maybe sort of what it is. But all of a sudden, when you start to get that motion data, right, that the Doppler data that we're talking about here, does that make it easier to run that prediction part of it?
Definitely. So, if you've got an object close by, you're going to have so many points on it that you can tell a lot about it even without the Doppler data. But at longer ranges, imagine there's a car parked on the side of the road, and you might only be getting a few dozen returns off of it. And every time your LiDAR sees it, you're getting a different set of dozen points. And now you have to ask the question, is that car pulling into traffic, or is it staying parked? Almost impossible. Almost impossible to tell what from a handful of points. I mean, you don't even know you're observing the same part of the car. But if you've got per pixel Doppler data, now you all of a sudden have a signal that says, actually, I know that every one of those points is moving in a coherent fashion into the path of the road. And now the car can determine much earlier that you've got a hazard up ahead and can take appropriate action. And this is really important in the way that we build our autonomy stack in particular. So we have an approach that's based on simulation on the car. So basically, as the car is driving around, we're running simulations predicting what everyone else is going to do and all of the things that we might be able to do. If we have a better model of what other agents are going to do, it means that our vehicle can pick better actions for us, which means better, safer, more comfortable driving.
Yeah, and I love that example. I'm not going to name names, but I've definitely witnessed a very big name in the full stack AV space. Their cars have this exact problem. It's fascinating to see an autonomous vehicle on the streets of a city stuck because there's a parked car and it doesn't know what it's going to do. I've literally seen this with my own. I stumbled across it. San Francisco. Oh, I've already said too much. But I think this is a very real problem, and I think the challenges in a trucking. You think about the fast closing speeds, and there's some unique challenges there. But you're dealing with stuff that is really close into you. You have maybe occlusion, right? You have maybe a pedestrian stepping out from behind a vehicle, right? Like, so even though you don't have quite the same speeds as maybe you can stop a little bit faster because you're a little lower speed, but like the stakes are so high. You're in a community with people coming and going and doing unpredictable things, and you'll have to predict that, right?
Yeah, I mean, you have a line of cars parked on the side of the road and some pedestrian cutting between them. And the cars are blocking your view of the pedestrian. So all you're getting are, sort of a few LiDAR returns for the head. But if you've got a motion cue that says that head is moving towards the lane of travel, whereas the parked cars are not moving, again, that gives you a really powerful cue that you should be segmenting and tracking that pedestrian because they might be about to do something dumb.
Yeah, and like a lot of that like typically has been done by cameras too, right? Like, or like a lot of classification and sort of that, figuring out what's around me. Like and what it is, which is where you start, right? You have to say, okay, so there's something here. Okay, now I know, through my camera, we run our, computer vision, and we've identified it as this typically, right? And then you run the prediction models. Just with this evolution in LiDAR, are you able to do more with LiDAR? Are you doing more fusion? Like, how does it take less pressure off the camera? Because I know, these are probabilistic systems. You don't have as much determinism as you have with the LiDAR. How's that changing?
I think there's still going to be a really important place for camera, especially at long ranges. Even if you've got a handful of points on an object, you'd still really like to know semantically, is that a bicycle or a motorcycle or a car? Because that, for our system, is going to inform which prediction models we use. Cars and bicycles behave differently. And that's something that a camera is really good at. But once we have this sort of semantic class, then the challenge is, okay, yeah, it's a bicycle, but are they moving? What direction are they going? And with the additional capabilities of a 4D LiDAR can really help there.
Yeah, absolutely. Yeah, what do you hear from, as far as when you're talking to customers like Ed about their unique challenges in these kind of denser urban environments, what are the things that jump out and the challenges and the opportunities?
Sure. I think there's actually a number of things. I think, you're going to split them into across performance topics, across kind of reliability, robustness, cost, scale. It's the whole package has to work, right? The best mousetrap is not always the right thing for the job. And so I think, on the performance side, we spoke a lot about that. I think there is other elements where typical, as Ed mentioned, 3D LiDARs have some challenges. We've heard about that from other OEMs around, seeing kind of very reflective targets like the blooming that happens, or potential interference with the sunlight or other things. These are challenges that we have been able to address with the 4D LiDAR or FMCW technology. I think the other side of it though really is how you actually make a product that is automotive grade. It goes back to scale, right? And are you able to deliver? Are you able to meet the quality requirements?
Mm-hmm.
Are you able to actually do that? I think that's one of the things that we've spent quite a bit of time on. I think it's been the past 7 years, and evident by some of the recent also wins and also the last conversation also that we've had, and working together closely with Ed and May's team, is to be able to get all the technology down to the chip level, as we've talked about, to remove the components, make the assembly process much simpler, so you have more of an automated assembly process, and then at the same time, able to actually run them through these kind of strict qualifications, standards, protocols, reliability, shock and vibe. Different vehicles have very different requirements in terms of what you need to actually be able to survive, and the life durations, different uptimes, and so I think if you kind of start on the wrong path, it could become pretty challenging to actually make the end tower eventually working, right? So that's something that we have, I think, taken a specific path on that we were pretty happy about.
Yeah, well, time flies when you're having fun, and we are getting a little bit short on time, so I want to ask you both for sort of your thoughts on where this is all going. Really quick though, Ed, I love this vehicle. If you have a chance, take a look at the May Mobility vehicle here. Ever since I've been following the AV space, there's been a lot of talk about how this technology can benefit people with disabilities. And unfortunately, it's been almost all talk. And one of the things I love about May is that you guys are doing it. This is a fully accessible, wheelchair-capable autonomous mobility system. Where are you going with that? Why did you pick that, right? And where are you going from here?
Yeah, we actually had our first wheelchair accessible vehicles very early in the company. This was always a priority, and the short version of the why is because it's the right thing to do. And I know that sounds corny, but the vision that we have is cities being more beautiful and more accessible, and being great places that we want to live, and that means providing transit for everybody. But even if we take off sort of the feel-good vibes of it, it actually makes really good business sense. So working with cities need to have these as requirements. So us being able to check the box of accessible vehicles opens up additional customers, opens up additional business. So it's a really happy place for the entire company that we get to do the right thing and we get to do well at the same time.
And you're helping cities solve problems that they have. And yeah, I was my sister's disabled. I was a caregiver in college, and I know what it's like to, for people who have disabilities and don't have that mobility. And I know that for a lot of cities, having, good, efficient, reliable paratransit operators it's just not a business that attracts as much investment and certainly technology as it could. And so I just think it's super cool that you guys are doing that, and that you're proving that, as you say, that this technology can do good and do well at the same time.
Yeah, a lot of paratransit, you have to call 24 hours ahead of time to book a ride. And you can imagine the impact on someone going to a friend's house for dinner on a spontaneous basis. No, that's just not a thing. And you replace that 24-hour ahead booking with 7-minute on demand, you can really improve people's quality of life.
Yeah, absolutely. And it's an invisible problem because people are not out and when I've seen firsthand when people who have not been able to be part of their community suddenly get that ability, even if it's just because someone volunteers to drive them or something, it's an amazing thing. And so I'm really just so excited that there's someone in the space who's walking the walk and not just talking the talk. Take us home here. What do you hope to see out of the future of your collaboration with Ed and May?
I think, look, I'm very excited to be working with a partner that is very focused on scaling, today and in the next couple of years for actual commercial deployments. Have a thoughtful approach about the business case, but also the benefit to the cities, and a model that is very collaborative with the cities. I think that's very important. And I think together. We are going to really bring this technology to the market in a way that can be even, as Ed mentioned, safer, faster, more efficient, and hopefully real for the years to stay. So that's what I'm really excited about.
Okay, well, I'm really excited for you both. I'm really excited to see this vehicle out there in the world and doing good work out there.
Awesome. Thank you so much.
Thank you both. And thank you to our audience for joining us.